So we can carry on with our script file here. So for now, let's not load any packages. So hopefully you've installed the first 6 there and the last 3, and if needed, we can install more. So our environment is still empty here. What we want to do now is to get data in. The data is saved in that file that I've given you, export_data, in comma delimited format. And as soon as we read it in, we create this object data. So if you execute that, keep an eye on what happens here in your environment. So we have all the files here. So as soon as we execute that one, now you see the data object here in your environment. It's got 45 observations for 4 variables. And it doesn't mean every variable, it can include missing observations for some, but the longest time series in that of that 4 variables has 45 observations. So you can always, if you click on this now here in this window, you will be able to visualize it. Here we can see what we have. So you can check that did it come across as you believe it should. All the variable names there, we can see this one, the last observation is an NA. Sometimes for some of the packages, it presents a problem if you have missing observations. So we have to deal with that. So you will see now that we have worked on our file. So the script file is, the name appears in red. So just make sure occasionally to click on this save icon, the little disk that so if you click on that one, it's like saying file save, the save as saying file save through the menu, then it's updated again. So whatever changes you made up till now will be taken into account. So now we have the data, we see it here, and we can do, sometimes what you want to do now is simply inspect the data, graph the data, look at summary statistics, means, minimums, maximums, standard deviations, whatever. Or if you use this head function, so that data is an object or data frame, and then we can apply functions to objects. So the function is head, and that will just show a few observations, because you can see the variable names and you can see a few observations. You can summarize the data, and typically how R is different to other software packages like Stata and R. There's very tightly in eViews you have a work file and you can open a program that talks to that data. Stata as well. You have a dataset.dta file, and then you have a Stata file with code that only talks to, you open it like it's like 2 people in one room talking to each other. You cannot talk to somebody that's in a different house or a different room. But R can have multiple data sets and one script file, and multiple script files that uses different data sets. So you can have many of it open here, and that's why you have to tell the software, I want to work with the X variable in that data in this data set. So if I summary and how I do it, either by specified inside the brackets, like specifying the name, or concatenating it with a $sign. So for that reason, it's a good practice to keep these names as short and abbreviated as possible, not to have to type too much. So if we run it, we see that that variable exports has a minimum value of 418 rand billion, I think. The median, the mean is 86 million or billion. I'm not even sure. It's not a good thing to say, but whatever the units are, and the minimum and the max all are here. The summary of that index will not be so useful, so it is an index. Typically, if it's a standardized index that takes values between 0 and 1, then you can see if the mean is 7, you can know there was a lot of growth towards the end. So, but I mean, we use this to get an idea of the data that we work with. Instead of just double-clicking on the data set in the environment, you can also execute a command view data. That will do the same. That's the command associated with just double-clicking here and see it. Now the next step, if we want to generate new, so you can stay in that data file and add more variables in that data object, add more variables there, or you can keep that kind of as your raw data. That may be good for a project, and then start adding. So in order to do that, you can just assign that to a new data frame. So if I do this, then you can see it's now an exact duplication. And now I add a couple of variables. All the variables that we generated in eViews, we can generate here. And exactly similar to eViews, we use the log for natural log. That is different than if you generate your logged variables in Excel. You have to use the function lin. And Stata uses lin. So what we want to use is the base E, the natural log transformation. So at least in R and eViews, we both use log. But if you do this in Stata or Excel, you use lin. And remember that assignment operator, we do it as alt minus or alt dash. So if we run, you can run all of that, but let's just do the 3 log transformations. You shouldn't get any error messages down here in red, because then maybe something is wrong. You didn't refer to the right data frame object to use. Now the dummies. What would be good practice? What would be easier to just create them in your Excel file before bringing it in, or writing a few lines of code? Probably it's easier to do 0, 0, highlight, cross on the corner. You have the zeros, you type the ones. Much faster than writing a double if then else control structure to get it done. But for purposes of replication, if you want somebody else to because maybe later on you decide to test something different and overtype in that Excel file a different version. So if you want to do good housekeeping and record what you do step by step, then it's good to put your calculation here in hard code evidence of what you've done. Of course, there's different ways to do this. I've seen when the honor students did this assignment, some of them wrote 20 lines of code to create one dummy. There's many ways to do it. One way here is just to say, let's focus on that bit prior to 93. Remember, this is the case where we said we have 0, 1, 0 up to 93, and then 1s up to 94. But then we decide to place weights on it to model that gradual transition. So it must be up to 1992, and here you can see I use smaller than and equal. That so another way would be to say smaller than 1993. Instead of having an equal sign there, but to put a 3 here. That would be exactly the same. Get the same job done. Or you can say up to and including 1992, make that 0. Then we think further. And the further is, if it is then smaller than 1995, so now the else is 93, 94, and 95. So those 3 years will get a 0.5, and what remains is from 1996 to the end. That gets a 1. The financial crisis one is a little bit simpler. It's just up to 2009, it's 0. Smaller than 2009, 2009 and 10 gets a 1, and then 0. And COVID is only 1 for 2020. Can you see we use the double equal sign? And then otherwise 0. And the commodity dummy 0, and then 1s for 2024 to 2028, otherwise 0. So the check is always, if you run it and then view it, that it worked out as you hope, as you hope. So for instance, for the democracy dummy, 0s up to 92, then a scaling in where we put weights, and then 1s up to the end. So that is the check that you've done it correctly. So it's always a good idea to at least check that what you think you coded actually happened. Yes?
What does the dollar sign do, and also the difference with the double equal sign?
Okay. The dollar sign says go to this object and use that variable. So in this data frame, use that variable, because it also exists in that one. There are different ways in different commands how you can point to which data frame. Sometimes we put a comma and then say which data set to use. Sometimes it's in the front. The packages have different syntax to specify where does that X variable come from.
And the double equals
the double equal is just equal. It's the yeah, it's just the way we code it. I think in Stata also, if you say if that equals, we also use the double equal sign. So just smaller than, we can use just like that. Smaller and equal, like like this, and bigger, greater than equal is greater than an equal, and then equal is two equal signs. Let's just see what it says if we do this incorrectly. It's complaining. And then we also can use the Boolean operators. The ampersand for and, the down, what is that? Just a down little line for or. And what else do we have? And or. Yeah. So we can also say bigger than this and smaller than that. That's another way to specify your range that you want to work with. So sometimes it's also a good idea to write out your results up to that point. Sometimes it's to share with a co-author. I've done some data creation. Maybe you want to check if you agree, or you just want to keep record for yourself. So now you can see there's no output file. There's no file here with the name exports_out.csv. So if I write it out without having to say what is my working directory, where I want it to go, if you execute that, it will come here. So everything nicely together. And now we have all the ingredients, we have all the variables which we can now use to do analysis with. We have already looked at, yes.
If you've done something where you just click, then you add something just enough to do, you can
Say again?
want to undo.
One of those. Yeah. For edit undo. If you've by accident deleted something, then you go to edit undo. But if you have typed multiple things, then it doesn't take you all the way back. You have to find your mistake not 10 steps down the line, like using the Control D and think you're executing a Stata command. We've already done some of the statistics. Now we want to use the Stargazer. That's probably a little bit better than what we've done up there with the command. So now will be the right time to launch that, to load that package. It will just tell us it has now loaded, and it actually tells us the author of the package. And this is a very nice package to use to display your data nicely in columns, make nice tables. So if you go to Help Stargazer, you can investigate the different options that are available, where you can use it. We use it later on to table our regression results as well, but here we just, and you can make your windows, the size, you can alter that a little bit. Now this shows us all the variables that we currently have on that data frame DF. You can write a heading for that. and specify. There's lots of options that you can use with that, and this is basically what you get. We can see all the variables have 45 observations, except for the world income, and of course the log of world income that's based on that one. So in typically what we do next is either to look graphically at our data or look at correlations, the typical things. Plot the data over time, look at scatter plots, fit a line, look at correlations. So there's a few options here for correlations now, quite a few, of which there's not one that's really perfect. You will see most of the packages produce the correlations in one little table and the p-values separately. There's not one that gives us this equivalent. At least that I've discovered now. There's a if we view this, there's not one that gives us exactly this one that I've come across, and you will see that I've looked at about 6, 7, 8. I don't even know how many that I found on this website. The link is there. So I selected a few from there. So using this library, what can we do? Sometimes we now don't want a whole big correlation table between all these variables. If you just do correlation table and this on the date, it will include everything. So that's why we just want to select a few of those. And here I will override that data object if I do this. It doesn't really matter, but maybe you can call it data 2. So I load the libraries that's necessary here. And you can see sometimes it gives you a warning, but it's simply that it notifies you that it was developed under a different version that you are using. So if you want, it's probably best to select the variables by name from the first component here will be from which data set. So I want to go to data frame DF and I want to select those variables. Or if you know they in certain columns, you can refer to them like that. That might not be so convenient. You'll have to go and exactly see which ones those are. But those are the ones I want to select. It's probably best to select them by name. So go to object DF, data frame DF, and select those variables. You can also select year if you want to keep that for some reason. So that will keep the year as well. And you can also select and assign it to, it will overwrite that one. So maybe use data 2, but it doesn't matter. So if we assign it there, it's now there's 3 variables in there. We have now overwritten that one. So if you don't want to do that, give a unique other name. And now this will now actually calculate those correlations. And if we use the stargazer package, that will plot the correlations. And if you're interested in the p-values, we can get that down here as well. And those are similar to what we 0.95 and 0.77. There's another one here which I think you can see. You can make it as hard as you want for yourself by writing detailed code like this, and all of this boils down to exactly the same as here. If you run that, you'll see that what you get at the end, it's just obtained a little bit more effort. If you want to practice your coding of your control structures, you get it here as an object as well. And if you then print it by using the stargazer package, then you get exactly the same. So there's many paths to Rome. The question is there, can we just write a few lines of code to change this so that it looks like that? Oops, sorry, wrong version of eViews. This is the student light one that you can't save with. So if you want to try that and share it with us, just a few lines of code to put those things on a single table.
Sorry, Prof.
Yes.
What does it mean if my stargazer is not running?
Have you loaded it?
Yes.
Have you said library stargazer? Have you done this?
I think in the installation, I think that was maybe a package that wasn't.
One of the components.
Oh yeah, it won't be installed.
Oh, okay.
Yeah, typically if you say, if you install Stargazer, you will see that a whole lot of other packages, which is part of that bigger tidyverse package, are installed. And sometimes you see a little cross that but what is that if it says that it wasn't installed, this one or that one? It's kind of a key package that we have to get to work for you. We can have a look as soon as we get time. For the moment, I think just try to install all of these up here and then load all of them. I don't know, we'll see where we don't have all our bases covered there. The best one, I think, is the performance analytics package. Not so much to put in a paper that you want to send to applied economics, but which help us learn about the data. So if you can also investigate a little bit of the information here. If you did it show no documentation? It was available earlier, but if I think you can still access it here in packages and then open that documentation. If you go and look packages, it is alphabetical. So if you go to performance analytics, it's not here. So what we want to do again is select those variables, and then if we execute this, what we see is a nice some information. So on this row and this column, we have the log of x, and here we have the log of y. So if this will be the correlation between log of x and log of y. What the software does, what this package does, the larger the coefficient, the bigger the font. And then that's the significance level. It doesn't show us the p-value, but it shows us the rejection, the level. So we reject the null of no correlation at the 1% level.
It's giving me an error here saying that you can't find the function select. Is it under
The select, for that you have to do the select, you have to install the package. We've done it earlier. The first time we selected. These two. So just go to where the correlation analysis starts. I think it's the second one. You need to just load that one to do the select.
I'm just going back up, please, Paul.
Okay. Just make sure those, I think that HMISC is what we do here. It's for this correlation, but just the two small little tables separately. So we can see a positive correlation, and the other one that we are interested in is log of x and the log of the real effective exchange rate, and that has a negative correlation, but it's also significant at the 1% level. And here we can see basically a plot of ln x and ln YW. So it's a positive relationship, and here we see ln x and ln RER, and here is the one between world income and effective exchange rate. So we're interested in that picture and this picture. And there's another option. If you put histogram to true, you also see, oh, I'm now a little bit ahead. So if you select that, you will also get a little bit of an idea, are the distributions of the variables normal or not? Is it a little bit skewed? What? But I mean,
Still not getting the pamphlet. And that means
so even executing those two and or loading and loading this package. Have you load performance analytics? Did it load without? Did you see the without error messages?
still says error.
Does it say? Okay, we'll come back and just see what that can be. Yes.
They have to install it because there wasn't a line of code to install performance analytics.
Oh, you know what? Kenny points out something important. Performance analytics was not here. So I probably installed it, yeah, in a different. Because once it's there, it will not complain. So you just have to run this line of code and then load it. So if you along the lines start wondering about things, remember we said up to 94 the price mechanism broke down a little bit. We can also investigate a subset. If I only want to see what happened up to prior to 1994, you can just subset data that you have based on a specification, an option, and that option is that the year variable must be smaller than 94. So if we run the code at line 2012, just keep in mind the results that we have here now, and then if we subset that and plot it, we can compare.
Same data set numbers.
This is now following, we've just run the performance analytics to get this, and then this will be like just investigating it in the democracy era from 1994 onward. And obviously we don't need to view, and you can see here now I have assigned it to a data set 2, which would be better to do it up higher up as well. So when we want to compare that one to see, so then you can see prior to 94, the correlation was much weaker and only significant at the 10%. It even makes the little asterisk smaller. Yes.
On line 212,
Yes.
are you saying that we are subsetting for the observation before 1994 or after? Because I see the last time. Or is it?
Yeah, it's before. Yeah. Yes. Yeah. Up there it actually says post apartheid. Yes. Let's fix the comment that is. It's apartheid is such an ugly word. Let's use pre-democracy. That sounds. It's not really better, but it sounds better. Yeah, thanks for picking that up. I think the other example was looking pre and post. So here I just thought let's investigate how it was before 94. And doing the one with the histogram, it clutters it a little bit to me rather than adding a lot of information. So I prefer to put histogram to false. The correlation plot, or let me just give you time to, let me not just rush through. Do you all get that result? Not?
Yeah, this one is okay.
The histogram one, not.
For me, I'm getting an error, so I just thought.
And the only change is to put histogram to change the false to true, and then it doesn't work. It's the same, it's the exact same command for subset 94, setting the histogram to true.
But the code here, there's diagram manual equals now this code.
Yes?
It's very different from the code on line 214. If you expand that side,
Okay, let me do that.
okay. Yeah, the code is different.
That you have.
But
For-
let me try to put the last part of the first code.
Oh,
Yeah, because for this one, after true, the method equals here, so comma, PCH equals, yeah. There were some things there
oh.
which made everything difficult. Check that out. Okay, done.
Inside.
Well, probably a copy paste and then the code, something else jumped there. Or maybe sometimes you highlight things and you drag and you move other things. Not unintentional. So let me know if we can, the last one that we have is this, and then we can
This one, the one that
go on to the regression. So this one is nice that you see graphically, especially if you work with a panel data set and you start having like 10 variables, then you can have an overall picture of your whole data set. Or for micro applications, cross-sectional applications, we sometimes, in time series, we don't have a large number of variables, but cross-section and panel we tend to have. So can we move on, and then we will leave a little bit of time off camera where we can just sort out problems if needed. So the core plot library, and we should also make sure that it was one that was installed. It feels like that can be one of those that we may have not. It's one that we also have to install. Yeah, so perhaps if you get a problem with that one, that will be the reason. So that one will need to be installed. And then we down here at line 190 or something.
Sorry, what's the...
I'm going to, yeah, you'll see the name just now. This one, CORRPLOT. So now, if you, after installation, you can load it. And here are just some specifications. As it happened, this one was now written for that subset. up to 1993. So if I select this code, it's just that I personally think this is less helpful, but it's a different view to look at things. You get such a temperature map, kind of. Blue is positive, red is negative, and across means not significant at 5% or something like that. So I don't think this is so useful, but that's even less useful. But maybe for really a large big data set, it will give you a bird's eye view on negative and positive and significant and insignificant. If you use LaTeX, then you can also, this will give you the LaTeX code directly that you can take to Overleaf or whatever LaTeX version you use. Oops, this is also that one we need to load a package for that. Is it Xtable? Yeah, so we have to load Xtable, and then you will see the LaTeX code, many special characters in between. Why didn't it? There's something missing now with this code, but I will have a look at that again. Maybe something dropped out. But you get like the backslash.
It's 268 instead of S10.
Oh. There's no?
It's 268 LaTeX on that one. So we should change to Xtable.
Xtable.
Yeah. And then type the last part.
Yeah? What must I type?
I think we should change from LaTeX because we are not using LaTeX.
Oh, yeah, but that's just a demonstration. Yeah, when I ran this at home, you get that LaTeX table codes with backslashes showing the column divisions, etc. So for us, we can, for now, just ignore that. Okay, so that's a lot of correlation analysis. Probably the best are the performance analytics, and the one just give us a simple table for correlations and p-values. So if we want to, that is where an interactive package is probably a little bit easier. What we can get done by just selecting two variables, open as a group, view a graph, and do a scatter plot with a line. We need a few lines of code. So basically, if you have the code ready, you just need to specify the variables that you want to use, the colors, the minimum and maximum of the axes, etc., etc. But once you have the code, it is actually quicker than accessing many menus, clicking through. So it's 6 of the one, half dozen of the other. And people have their preferences.
Sorry, I'll just scroll up. I just want to see what you selected. Thank you.
How did you get the library?
This one, I think the library would be ggplot2, part of the tidyverse. Sometimes the legend will be on top of the data, then you can move it to the bottom right or...
His graph is done.
Is it perhaps this one?
I think so. Maybe he didn't run just to. Oh.
Yes, that is.
So this is exports and the price variable, the effective exchange rate. Okay, now we've done enough preliminary analysis.
Yes.
But that is what you should do. You should not go click, click, shoot, shoot, regression. And in this case, code, 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 regression. You must say, Monday, Tuesday, Wednesday, I live with my data. Thursday, Friday, I model the data.
Yeah, I was about to ask something though. In ERSA, you generate the dummies, but as we go through the code, we do not see anywhere where you are getting this inspiration for the dummies that you are creating, as opposed to previous. You show the graph, use the text.
Oh, yeah, no, now we get to that now.
That's what I was thinking.
Yes, yeah,
Maybe that would also be.
yes. That is now, but it's not in the code. We will have to put a little bit more code to get exactly the same. I haven't. So if you look at this, the regression analysis, the package that I've used here is LM for linear model. And now we're going to create models. The model one that we create here, look at what variables are we putting in. We put the dependent variable to the left, and maybe I must just do this. I apply the function LM to that object, that data frame, df. The dependent variable is log of x, ln x. That little tilde sign means it's the equal sign if we write it out mathematically. So that's the dependent. The tilde sign breaks the dependent from the independent variables. And if you include more than one independent variable, you put a little plus, the plus sign. And this will now run that. And let's see if this help works. You will get some information here on fitting linear models. Have we loaded? So then we run model 1. So it doesn't show anything yet. We've just now put all the results in an object called model 1. So it's a placeholder to hold the coefficients and what. And you can see here the object is here. It has a list of 13 things there, and maybe if we click on it, it will be quite messy. So we definitely wanted to show it to us in a better format. Model summary will already show it much better if we assign a model summary, if we then show the summary, that will then, now it will look like output from an econometric package. And maybe that's already good enough. But typically, when we put our results in a paper, we table it somewhat better. Also, to try different rival models, I have simply here, and again, I see the command here is not updated. I've just updated the code, and so this must include all of the dummies that you'll see in there. So the comment is not reflective of what goes on here. This is now the model that we estimated. It is the model equation 5 in, which is down here. So you can definitely code all of the intermediate steps as well, build it up. Here we have just modeled the one without the dummies, and then model 2 is the one with the 3 dummies for democracy, COVID, and the commodity price boom. So if we run the model and then display a summary of the model, the same thing will happen, except now we will see all of the variables are included here, and we can check the parameters look similar. It just puts the intercept in the front. And the same thing, if you do this in R, at this step we merely focus on the estimated coefficients here. If you each time want to see the fit, the graphic of, before we get there, having it nicely tabled for a research document, the research paper, if you use that stargazer command, this is now what is useful to report in a document. The first model, number of observations, etc., and all the parameters. But you can refer back if you really want to change this from standard errors to t-values. You can do that. You can display p-values. You can choose if you want to put the asterisks here or next to the standard errors. You have all those flexibility, which is a preference. And it shows 1 asterisk for 10%, 2 asterisks for 5%, and 3 for 1%, the standard levels of significance.
Sorry, Prof, I'm not getting any of this output when I'm running.
This is also stargazer. If you didn't get that block correlations, you will not get this. So it's important that we get that to run for you. And then just the final thing before we move on is to plot the results. And let's just see what goes on here. I'm going to plot the actual exports. I call that Y1. And I plot the fitted value that we grab from the model 2. predict will then show that that function will then give us the fitted y, the y hat, and residual applied to the model will give us the residual. So you can choose this name here, this object name. I chose fitted. You can choose y hat. You can choose exports hat. You can do whatever you want. You can call this res or reset or residual. These functions are fixed, and the model is fixed because we saved the results in model 2 and model 1. So if you want to plot model 1 to see that fit with the large over and under predictions, you can just change model 2 to model 1 and get the results for model 1. I've cheated a little bit here. The one observation for the fitted will not have an observation for the for 2024, and that then requires a few number of lines of code to put the variables in different data frames and combine it again. So I have cheated and just omitted that last observation. So if I then plot, undo, make a little bit more space here. So if I execute that code, don't yawn. That means we have to do something else now. Then that gives us the fit and the residual fit. And typically, if you're busy with, you can also change the code or duplicate the code to have model 1 and model 2. I don't know what is best, or even pass the name of the model as a parameter, so that you only have one set of code and the different model comes in. So those are skills that we build as we become better and better at programming this. Do we have lunch at 12:30? So half an hour. Yes, Marima?
So, in e-views, we would have those, the actual line and the fitted one.
Yeah.
But here, are we also able to have those two and this one on one?
No. I haven't tried it. I'm sure you can. Then you will have a left axis, right axis, and plot these two variables on the left axis and that one on the right axis. Or in eViews, the residual is on the left and yes, you will be able to do it. And normally the AI for R code is quite good. You can actually, if you prompt and said, I want to plot variable X, Y and Y fitted on the right axis, I want to plot the residual on the left axis, show me the code. Then you kind of get the code. Just to give you an idea, if it's still here, if you prompt, and it's never 100% perfect, but it gives you something to work further on. it can give you a set of code that you can then develop further. So the next step will be to think why this is not the end of the road. If we transported ourselves back in time to the 1970s, this would pretty much be the end of the road. We would look at the Durbin-Watson and say, we will fail it, but then say we will live with it. This is literally how it was done. But now we know better. And that's what we will discuss next. That's why we now have to learn for 3.5 more days. No, not really. Just 1.5 more days. to address why this is indeed not the end of the road. So if you still have problems that we need to sort, maybe we can just at the start of lunch look at that and steal a little bit of our lunch, and then so just keep R open and everything, so that when we move on, now we can move a little bit to theory again. Oh, and the good thing is, if you it's always a good idea to maybe save just before you leave. And if you close, then everything will be nicely wrapped up and be there for when you come back. If you have some of those boxes ticked, you can later have so many things open, and it gets quite messy. And then you start tidying up your desktop, and you move the folders to different places, and you come back and you don't know what that was. And maybe then you start creating non-final versions of your code, and that gets confused with your latest models. So if you then close it, it will ask, do you want to save it? And it will save it to that project, and later on you have an updated version. So where do we go next? We go back to our lecture material folder, and now we will go to non-stationarity and implications for our classical linear model. So here we will go to the lecture material there, which I have open. Which I actually don't have open. There's also a summary that I have uploaded that gives like a timeline So this is, the purpose of this lecture is twofold. It's going to motivate why we cannot all pack our bags and go home and we're done. But also give a little bit of history of why that is, of how we arrived at the point that we are now, the way we do things, we do it now. So I think we can start slowly. It's almost break time, and then afterwards we can just carry on discussing. As I said, there's also a roadmap which shows us. You can see there are dates going back to forever when we started having the OLS as a tool. 1936, general theory of Keynes. And then there's a few, as explorers explored the world and discovered new continents and new places. In my mind, I see they planting a flag and then carry on, So there was a few scholars over time that planted flags to bring us where we are now. And back in 1926, there was a little flag planted by a guy with the name Yule. Then a lot of work were done in the 70s by Granger and Newbold and others. And then 87 is another flag planting occasion. And then we don't go all the way until today. We just go up to there. And around here, there's then an explosion of other techniques as well. Or maybe as we progress up Everest, we plant a flag. So that's the idea. But let's just talk through it. And I think it's a little bit too much information for now, because we discuss it in detail just in lecture 3, 4, 5. But this is, sometimes if you already know a lot, this can be a summary of history. Sometimes it's, once we're through with lecture 5 and 6, then it makes sense to come back here and read this paper by Ventosa Santolaria. It reads a little bit like the history of the co-integration literature. Together with, you can see chapters 1, 2, and 4 in Harris and chapter 11 in Wooldridge. So it looks like repetition, but these notes I wrote to, there's always a break of a week in between. So sometimes we just have to find a common knowledge and say, this is what we're busy with. This is our focus, and mostly our focus is on the multivariate models, not so much on the univariate models, but this will help us a lot to understand things about that variable and that variable and that variable on its own. So that's why we need the univariate time series theory as well. So through the ages, as you've seen on that timeline, least squares, still, it's actually, it's interesting that it remains our workhorse for so many analysis that we do. It's by a long shot no longer like the be-all and end-all, but it's still informative. When we build a CGE model, when we build a DSGE model, we can investigate the relationships that we want to model there as well, even though we go back there to more of the micro principles. But these things live alongside each other. So over the past 40 years, so what will that be? That will only be 1985. So it sounds like a long time. Sometimes you see people mention that 1980 is as far back from today as like I don't know what, 20 or so is from. So yes, over the last 40 years, a lot has changed. The first time when economists really started paying attention is in the 1970s. By that time, quite a bit of macro modeling was attempted by central banks and other institutions. That was the time when the first macro model was built by Jan Tinbergen together with Professor Lawrence Klein from the US. Professor Lawrence Klein later received a Nobel Prize for that work. Jan Tinbergen built a model for the Dutch economy, and then he helped Lawrence Klein with a model for the US. If we now look back at that model specification, it's like a 5-equation behavioral equation model with a few identities. So it was certainly easier to be alive in the 60s. You could get a Nobel Prize for a 5-equation model, which now we even don't give it as an honors research project because it's subject to the Lucas critique. So with what happened in the 70s, that changed the path for macro modeling. What crises did we experience? What shocks?
Oil price shocks.
Oil price shock of 73, 79. That, for the first time, the world actually started to experience real inflation, double-digit inflation.
Also the US coming off the gold standard, the currency.
Things like that, complicated things. And suddenly those macro models didn't perform so well. They weren't so stable, didn't perform so well. And that kind of almost created a crisis in the macro analysis world. They formed the Cowles Commission, like old people coming together discussing the problems. And they actually wrote some guidelines, but that eventually gave rise to later developments. But a big thing in data and modeling is that when we model macro relationships, all the variables have these underlying trends. Mostly stochastic. It doesn't go up like in the fashion of how nature behaves, not physics laws. We model human behavior, so there's stochastic behavior, stochastic trends present. But sometimes variables very much have variation, but around a straight line. Sometimes there is a deterministic trend in there as well. Not too many economic variables we see like that, but possibly population growth. If you look at many countries' population growth, even though there might be a shift at some point, if you look at South African population growth, and I haven't looked at it so recently, it used to have a 3% growth. And then at some point it changed to 2% on average. But that has, that's one of the variables that we can say definitely have a deterministic trend. So if you look at that and the data that you have been working with, it comes in all shapes and forms. Some will be like this, like growth rates, inflation rates, maybe not even. Ratios maybe can stay pretty constant, like savings rate or government expenditure, but even those sometimes have a downward or an upward trend. But for the most part, our economic series do not have a constant mean. They are not stationary. And by stationary, I mean a constant mean and a constant variance, and covariance just dependent on the distance between certain fixed distances on a distance k between period t and t minus k. For the most part, we will see trends like that. True underlying stochastic behavior, like what? Name a few.
Stock market prices, maybe?
Stock market prices, exchange rate. Quite a few variables will have maybe not so much variation, but definitely not a fixed pattern of behavior. Especially financial market data can display behavior like this, where the variance is not constant. And maybe this is followed by a period where the variance is smaller again. And this is also not a stationary series. It also presents problems because a stationary series also needs to have a constant mean, a constant variance. And that is one where, similar to population, it's almost that as if you regress that series Y on just T, a trend, which can be 1, 2, 3, 4, 5, 6, or 1980, 1981, 1982, and you take that residual, you will have detrended the series. So detrending a series is one way of getting from there to here, and differencing is one way. Maybe we must leave it at this. And when we come back, it's like, let me say this, and then you have something to chew with your lunch. Chew on with your lunch. OLS was designed only for Series Z. And we don't live in a stationary world. We don't want to live in a stationary world, but it comes at a cost that we have to deal with the non-stationarity and the implications for our analysis. So when we come back in an hour, we discuss firstly what are the implications and how can we use OLS, but just and principles of economics, and OLS is a technique, and we can fix the problem and even improve, doing better as what we had in the 70s. Okay, so thank you. Enjoy your lunch.